of 8085 pin diagram and all the functions of the pin, right? Today we are going, this is the fourth lecture of microprocessor. Today we are going to see the instruction set of microprocessor. Since 8085 is an 8-bit devices and it can have up to 2 to the power 8, that 256 instruction, right? But mostly here we use the 74 instruction. However, 8085 use only 246 combinations, that represents the total 74 instruction, right? Within a 74 instructions we'll have to, yeah, within a 74 instructions we'll have to uh, write a program task. So there is a 74 instruction which is used for the users, right? Most of the instructions have more than one format, right? That we are going to see how the instructions are there. These instructions can be grouped into the 5 different groups, right? All these instructions is to be into the 5 different groups. The first group is the data transfer instruction, right? Data is transferring from memory to the microprocessor registers, general purpose register, and from general purpose register to the memory, as well as from input to the register, input to the our register to the output, right? So these are the only data is transferring, it is not performing any task, right? So it is called as the data transfer instruction. The first group is there. The second group is there, the arithmetic operation. It performs the arithmetic operation, that is addition and subtractions in various type, right? 8-bit addition, 16-bit addition, 8-bit subtraction, 16-bit subtraction, and all. So it is a arithmetic instruction, right? The third one group is the logical. Logical means and or XOR, all these logical operations it's performed, right? Fourth is the branching instruction. Branching instruction is called as the jump, call, or if this condition is, it can, we can say that the if and else and then. If this condition is not satisfied, then jump there. If this condition is satisfied, then perform this task. So it is used the conditional statement. It is called as the branching operations. And last is the machine control operation, that is the same rim and all what we have seen into the serial mode communication. Trap and all instructions will use there here into the machine. Enable EI, DI, disable the interrupt, enable the interrupt, right? So all this instruction is used, that is a machine control operation. So now we are going to see first the data transfer operations, right? Now, how the instructions format there, first we'll see that. Each instruction has two parts. One is the opcode instruction. The first part is the task of the opcode operations of the perform, and the second is the operand, right? What is the opcode and what is the operand, that we will see that, right? The first part is the task of the operations to perform, right? The second part of the data is operated on. Data can be given in the various format. It can be specified in the various way. It may be the 8-bit, 16-bit internal register, memory location, or 8-bit, 16-bit address. So this is the data 02. Now this, for example, the instruction is MVI A,02. The MVI A has the opcode, right? That is, on the net you will get the opcode sheet of instruction set of 8085, right? So MVI A has the opcode and 02 is the operand, 02 is the data. This instruction meaning that the 0T data can be moved into the accumulator, right? As now I just explained you, right? So now in this slides we need to clear the concept what is a opcode and what is a operand. So MVI A is a opcode, it is an instruction, it is called the mnemonics, but this mnemonics has a opcode, right? This is the mnemonics of assembly language, right? And this operand means what? It is a data. 02 is a data, right? Now, An instruction is an assembly in a binary format from 0 and 1, known as a machine code or opcode, right? So those are the opcode into the machine form. It is known as a opcode or machine. Due to the different way specific data or operand, the machine code are not same for all instruction. Machine code is not same for all instruction because each instruction has the different opcodes, right? So the size of instructions signifies how much memory space is required to load the instructions in the memory. 8085 instructions are of the following: 1 byte or 1 word instruction, opcode or operand in a 8-bit only, 1 byte. Operand are the internal registers are coded into the instruction, right? 1 byte instruction means what? Move, add, and, sub, or etc. All these instructions are the 1 byte instruction. Move a comma b means whatever the content of b, it will transfer into the a. So the move the content of b in a. B is a destination source and a is a destination, right? From source to destination, it will transfer the data. 0 1 from the move operations, and 1 1 1 is a binary code for the register A, and last three binary code of register B, right? So 1 1 1 is a B, 0 is B, and 0 1 is the move code, right? This is the first. So what is your code? Is 7 8. This is your upcode 7 8. Now see here, copy the content from accumulator into the C register. So what is your, so copy the content accumulator. Accumulator is a source, C is a destination. So move destination comma source, right? So now move has what? 0 1. C is what? 0 0 0, and A is what? 1 1 1. So what is the opcode of this? 4F. 4F hex code is there for this instruction. Now add the content of register B to the content of accumulator ADD. ADD means what? 10, right? 10. B means what? 00 00. So 80 is a upcode. There is a sheets, and in exam also it provide the upcode sheets also. No need to mug up the binary code or hexa code of this instruction, but you should understand what is the meaning of this instruction, how can it is decoded. So each bit invert each bit So now 2 byte instruction. Last one is we have seen single byte instruction, that is move, ADD, SUB, ANN, and all these are the 1 byte instruction. Now the 2 byte instruction. First byte is a opcode of 8-bit and second byte is a operand, either the 8-bit data or 8-bit address, right? MVI, those have I, it is called the immediate data transfer instruction. ADI, now here there we have seen MOV, ADD, right? ANI, ORI, XRI. So now this is MVIB comma along with 05 is data. Now the meaning of this instruction is 05 is transferring into the B register, right? So MVIB has a 606 is the upcode and 05. If the microprocessor will get these two, 06 and 05, microprocessor will understand this 05 has to be transferred into the B register, because 06 is the meaning of that, right? So load 8-bit data into the accumulator. How we will store load the 8-bit data? MVI A comma data. Data may be anything 00 to FF, right? So MVI A has a upcode 3E. and the second byte will store the data of second opcode. So 3E32. Now this is meaning that the 32 will transfer into the accumulator, right? So these are the 2 byte instruction. Same as the 3 byte instructions also there, but there it is used the LXC pair, right? It is used the pair of register 16 bit. So 3 byte instruction, first byte is a operand, second byte is a third byte of a operand, first byte is a opcode, second byte is a third byte of the operand, and third byte is a first byte of a operand. So the operand 1 is a lower byte and operand 2 is a higher byte. Now how we will write here LXIH, it is a HL pair but it will mention only H, right, comma 2500. So how we will write LXIH opcode has the 21. So first it will come the lower byte 00 and then the higher byte. This means that load HL pair with 2500. So the 25 will into the H register and 00 into the L register. Right? This is a 3 byte of instruction. Same as transfer the program sequence to the memory location 2085, jump 2085. So jump has a opcode, right? 85 is a second byte and 20 is a third byte. So for to store this memory location, this instruction we require 3 memory location, right? To store these instructions we require 3 memory location. That's why it is called the 3 byte instruction, right? So now this instruction it requires the 2 memory location. One memory location is 3A and second memory location is 32. That's why it is 2 byte instruction. This is single byte, 1 byte only 1 byte, 4F80. It is over the instruction. So this is single byte instruction. This is double byte instruction or 2 byte instruction. This is triple byte instruction or 3 byte instruction in data transfer or in any other also, right? Now, opcode format, we will see that. Opcode contain the information regarding about the operation, registered, use and memory to be used, right? This is the opcode basically. So it contains the information regarding the operation. Opcode means registered use and the memory to be used. The fix of such instruction. So now B has 00, C has 001, D has 010, E has 011, H has 100, L has 010, M has 110, and A has 11. Right? Registered pair. BC is 0, DE is 01, HL is 10, AFSP has 11. So this is a fixed code of all pattern, right? We'll see. Addressing mode. Now there are the 5 type of addressing mode into the 8085. It depends upon the data transfer or the type of the operations, right? The various formats specify operands and data are called as the addressing mode. किस addressing mode में ये instructions काम करता है? That is called the addressing mode. 8085 instruction can be classified in the following addressing mode. Registered addressing mode, right? Only the instruction those are having single byte, move A comma B, move C comma D, move A F H comma L, all only has a opcode, that is register addressing mode. Move ADD A, ADD B, ADD C, SUB A, SUB C, and all these are only the registered addressing mode, right? Now, the second is the immediate addressing mode. Those instruction has this I, MVI, ADI, SUI, NI, ANI. It has double byte required. Means the data is along with the instruction. It is immediate addressing mode. Immediately 05 transfer into the accumulator. That is the meaning. It has 2 byte or 3 byte addressing mode, right? Now direct addressing mode. The next addressing mode is the direct addressing mode. The instruction have their operand in a memory and the 16-bit memory address is specified into the instruction, right? The address of the operand is given in the instruction LDA, SDA, LHLD, SHLD, right? This means what? STA 7500. ये 7500 hex address में जो data होगा, right, that is transfer into the accumulator, right? The stored the content of accumulator into the memory, sorry, into the memory. accumulator में जो contain होगा वो इस memory location के content में stored होगा. This is the address. In that content data has to be stored. So this is the direct addressing mode. Directly address दिया है memory cell का, उसके अंदर तुम्हें accumulator का data डाल देना है. So STA LDA means what? Memory locations data is transferred into the accumulator, right? This vice versa instruction. This is the example of direct addressing mode. In case it is asked that the LD8 7500 instruction comes under which addressing mode, so you should identify that which instruction is comes into the which addressing mode. Now the next is indirect addressing mode. Indirect addressing mode means what? In this address of the operand specified the register pair, the address stored into the register pair to a memory location like LDAX, STAX, LDAXB. So in BC register, the address of memory location is stored. In that memory location, your accumulator content to be loaded, right? That memory locations contains to be loaded into the accumulator, right? So this is the indirect way. Now here LXI H7500, this is 7500, your HL memory location is pointing to the memory, right? And that inside data is M is transferring into the accumulator, right? So this we have written two instruction to perform a same task. The task was there कि 7500 का डेटा your memory accumulator में आना चाहिए. So we'll use these two instructions. Same the action will perform this STA 7500. This means that the in memory location of address of 7500 has a data that has to be transferred into the accumulator, right? The content of accumulator in a memory location 7500. Store the content of accumulator into a memory location 7500. The same operation is here. The memory location content is just reverse. It is LDA. Memory location content is transferred into the accumulator, right? Implicit and implies addressing mode. The operand is not specified in an instruction specified into the operand only within that. कॉम्प्लीमेंट मीन्स रोटेट लेफ्ट, तो एक बिट रोटेट करके वही हो गए. और all these instructions, those are the implicit instruction, it will done with only the accumulator, not with the other register. Rotate left, rotate right, rotate left with carry, rotate right with carry, complements, and all whatever the operations is there. So all these operations will perform with the instruction. So these are the addressing mode. These are the 5 addressing mode in 8085, and whole the instruction 76, all the 76 instruction is divided into this addressing mode. So now the next since 8085, your next data type is the arithmetic data transfer instruction. So these operations simplify the copy the data from one source to the destination. Data transfer between the register, data byte to a register or the memory location, data between memory location and register, and the data between input output devices to the accumulator. This type of instructions are there into the data. Data transfer between two register, right? B to C, C to D, D to H, H to HL, right? Data byte means immediate data byte it transfer into the register as well as the memory location. Memory location data can be transferred into the register, right? And the data is transferred between the register, accumulator and input output. Data in the source is not changed, right? The source of data. Data transfer instructions never affected the flag bits, right? Never affected the flag bits. Flag register will affected any arithmetic and logical operation is performed ALU. Then only the flags are changing or it is affected. Otherwise, data instruction doesn't affect the flag register, right? So, for example, LDA, STA, MOV, LDAX, STAX, MVI, LXI, all these are the example of the data transfer instruction, right? Arithmetic instruction. So these are very important. These instructions perform the addition, subtraction, compare also, right? These operations are always performed with the accumulator as one of the operand. Always one operand is in a one data. Operand means one data is an accumulator. Other data, it can be immediate, it can be in any register, it can be a memory. So other data can be. Suppose you need to do the addition, you need two number 05 plus 07. So 05 is always into the accumulator and 07 it can be any register. It can be direct, it can be memory location. So it requires the one data in the operand in a accumulator. The status of result can be verified by contain the flag. In this arithmetic instruction, your all flag status is affected, right? And that status is getting into the flag register, right? Addition. Any 8-bit number or contain the register or the content of the memory location can be added to contain the accumulator and the sum is stored into the accumulator. The instruction of DAD instruction is except it is the 16-bit DAD data directly in the register pair. For example, ADD, ADI, right? Any instruction, it first data is in accumulator, second data is in any register, and it will transfer the result into the accumulator only. Only the DAD instruction has the HL plus BC or HL plus DE, right? So that result into the HL. So DAD instruction is different instruction. Rest all are having accumulator data first, second data is in any register or directly or in memory, and result is into the accumulator, right? Same as subtraction, any 8-bit number or contain the register that contain the memory location and can be subtracted to from the content of the accumulator. Same. The result stored into the accumulator, the subtraction is done by the 2's complement as we have seen into the digital. Have you remember? So uh, the 7 minus 2. So minus 2 is converted into the 2's complement and the 7 plus 2's complement of minus 2 is added and then the result will comes into the one's complement. If the result is not a minus, so it is a simple. If result is a minus, suppose 2 minus 7. So now result is minus 5. The result is in a 2's complement. Again, it is converted into the one's complement. So the same, all the subtraction is done by using a 2's complement. Again, the arithmetic and instruction, it comes the increment and decrement. It is incremented by 1. It is a decremented by 1. It has a register increment, INR A, INR B, INR C, INR D, INR E, H, INR L and all. Same as it has a increment and decrement of pair. INX. X is represent the pair of the register H, L, B, C, D, E, right? INX H. H means what? It is a HL pair. INX D. D means what? It is a DE pair. INX B. B means what? It is a BC pair, right? It contains the pair of the sum. Third type is a logical operations. Perform 8-bit basic logical operations with the content of the accumulator, right? Logic instructions also modify the flag. This is also modified. Arithmetic instruction is modify the flag. Logic instruction is also modify the flag. Opcodes for the logic instruction includes ANI means ending, ANIA means ending with immediate data, OR means it is ORing, XOR means it is XORing, CMA means It is complement, rotate, rotate left, rotate right, rotate left with carry, rotate right with carry. CMP means it is complement, CPI means CMP means it is compare, CPI means it is compare with the immediate data, right? So and or XOR, any 8-bit operand contained in a register, memory location or any logical and or XOR with content of the accumulator, right? सबका rules है कि first data is has to be into the accumulator, other data it can be into the register, it can be into the memory, or it can be into with the immediate data, right? So it has a, and the result is in a accumulator. Rotate, each bit in a accumulator can be shifted either the left or right, but that is into the accumulator. Accumulator will shifting one bit by rotate left or right, right? Compare, same, any 8-bit number of register memory location can be compare equality greater than and less than. It will decided by the flag. When the number A is greater than B, and so what, the A is greater than B means carry flag is 0, that means the A number is greater than B. Suppose A is less than B means B is greater, so carry flag is 1, right? So the carry flag will give the status of whether the which number is greater or which number is less, right? Generally this instruction, compare instruction, is used for the J and C or compare non-zero and all this kind of. The content, compare instruction. Now the third case, fourth type is the branching instruction. Branching means what? Any subrouting is written into the microprocessor programming. Suppose if you want to check that whether which number is the smallest and the largest. If this smallest, then go for this. If this largest, then go for where the condition is applied. There is use the branching instruction. These instructions are used to transfer the program to jump from one memory location to another memory location within a program, from one program to another program, called as the subrouting, alerts the sequence of the program execution, either the conditional or unconditional. Unconditional branching instruction transfer the program to specify the label, address jump uncondition without satisfying any condition. Unconditional program control instruction, that is a call and return. And conditional branching program is transfer the program to specified label, the address is given by that. JNC means jump on no carry, jump on carry, jump no zero, jump 0. All these are the flags. Carry is a flag, jump is a flag, parity is a flag, minus is a flag, parity even, parity odd, jump positive, jump negative. Yeah, this is right. So these two instruction are the sign flag. These two are for the carry flag. These two are the zero flag. These two are the sign flag. These two are the parity flag, right? So these are the jump. Jump is used, your program, your control has to jump within a same program from this memory location to that memory. Call is used, your program from one program to the another subrouting, and that program is executed and come back to the same as call on no carry, call on carry, call on no zero, call on zero, call on positive, call on negative, minus, call on parity even, call on parity odd, right? If it is a use call instruction, your program is goes to the subrouting and then again return to the main program, so the return is there. Return on carry, return, return no zero, return zero, return positive, return minus, and return parity even, return parity odd, the same as. So these are the branching instruction. It is on the conditional and unconditional, only call and return, but this is a conditional, right? So these are the conditional branching. Machine instruction, there is a halt. All the program has the last instruction is halt, that means to stop the program. right? NOP means it is a no operation. This is used to calculate the delay and all, right? Subrouting. Suppose you want to display the 5 on the 5 second, number 5 on for the 2 seconds. So you need to write the 2 seconds delay. So there we use the NOP instruction, right? RIM and SIM instruction. This is used for the interrupt, right? And serial input mode and serial and um, uh, input and output, and also the interrupt register. Interrupt enable and interrupt disable, DI and EI, right? This is the machine operational control, right? These are full address, right? Now we will learn how to write the program of microprocessor. Write the instructions to load the two hexadecimal number. These are two hexadecimal. Try to understand, girls, please. Write the instructions to load the two hexadecimal number 32H and 48H. These are the data. H is what? It is a hexadecimal number, right? It is not a decimal number. 48H is something is decimal. That is 4 into 16 to the power 1 plus 8 into 16 to the power 0. So that calculations comes your decimal number. So always it represent to the hexadecimal number, right? So write the instructions to load the two hexadecimal number 32H and 48H in a register A and B respectively. Add the two number and display the sum on the LED output port 1, right? Forget about the output port वगैरह. So our task is first 32 and 48. 32 is transfer into the A and 48 transfer into the B. Add them and then display the result. Divide the program into the smaller step. Load the number into the register, right? पहला क्या है? Load the data into the register, right? Number data. Add the data, right? And third, display the sum on the LED of the port. The steps listen to the problem. The sequence can be represented in the block diagram and the flowcharts, right? This is sequence. This is called as the flowcharts. Always start and stop is a oval circle. Any data is loaded into the rectangular box, right? Decision making I will explain in later on. Load the hexadecimal number. This is your first task. What is the load number? A with the 32, B with the 48. So now immediate data is that what instruction will come? MVI A, 32, right? MVI B, 48, right? A में 32 हुआ, B में 42 हुआ, B में 42, 48 हुआ, and then adding a number B, ADDB. This meaning is that accumulator data plus B register data and result is into the accumulator data, right? And then out 01. So, right, output is written on your 01 and halt. So, this is your instructions, right? This is your flow charts and this is the comment of instruction. Your program is over. 32 is in a 48 in a B. It will add, it will result into the accumulator and then out into the port 01, right? This is your MVI A, 32. So 3E is your opcode of MVI, 32 is data. MVI B, 06 is your opcode, 48 is data. ADDB 80, out 01, D3 is a opcode of out, 01 is the address, and halt 76. So halt means it is a stop. It is last instruction 76. So this you have to store it into the memory location and execute your program. We'll see into the simulator how we will execute the program, right? So this is the basic program is there. Stored in memory and convert from the hex code to the binary code. So to store the program read write memory, assuming that the memory range is 2000 hex to 20FF. So now enter the program, right? So reset the system by pushing the reset key, right? This is the hardware demo, right? We will see that. So enter the first memory address in hexa key where the program is started from 2000H, right? Enter the each machine code and push hex key. For example, to enter the first machine code, push 3E, right? So push 3E means first is your 3E, second is 32. So this 32 will come into the 02001, right? And store the key and store the program in a memory location and upgrade the address 2001. And 2001 is 32. And again it is going on till 76 and then the reset system. So now the flow charts, manual lookup, hex code, monitor and binary code. This is your flow of writing a program. So now machine content 3E in 200, 32 in 01, 06 in 02, 48 in 03, 80 in 04. This is the address is always 16 bit, A15 to A0. This is D0 to D7, right? So D3, 05, 01, 06, 76, right? This is you are storing into the memory locations to run. 8 machines code required 8 memory locations. So microprocessor can only understand the binary code, every else. So microprocessor will understand only this, not this. This is for our understanding. So it is converted into the memory content, and my microprocessor or instruction decoder will fetch and analysis what to do with these instructions only, right? To execute the program, we need to tell microprocessor where the program began by entering the memory location and address. Push the executive key and microprocessor loaded 2000H in a program counter. Now program counter will point here 200H. जैसे प्रोग्राम काउंटर ये पॉइंट कर दिया, ये डेटा पे आ जाएगा, ये डेटा से इंस्ट्रक्शन रजिस्टर में जाएगा, ये इंस्ट्रक्शन रजिस्टर से डिकोड करेगा. दिस मीनिंग दैट द नेक्स्ट इंस्ट्रक्शन डिकोडर का डेटा जो आएगा वो टेम्पररी रजिस्टर में जाएगा और टेम्पररी रजिस्टर में से अक्यूमुलेटर में जाएगा. दिस इज द फ्लो ऑफ program writing, right? PC is transfer from monitoring the program to the output program. Microprocessor begins to read one machine cycle at a time. When it is a fetch and complete the instruction, it executes the instruction. When it fetch the machine code to store the 200 and 2001, execute the instruction MVI A, 32H. Thus the load 32 into the accumulator. जो मैंने एक sentences में बोला. This will continue till the instruction will fetch the halt. Halt, it will understand now it is a stop. Now no more instructions will come over there, right? So now how does the microprocessor differ between the data instruction, data and instruction code? How it will identify whether it is a data or whether it is a instruction. Data is also in between 00 to FF and instruction opcode is also the 00 to FF. But how it is identified between that? Microprocessor is a sequential machine. When the system is turned on, it began executions of the code in a memory. Now the question is that how does microprocessor differentiate between the code and data when both are in the binary number? It is very interesting conceptual questions, how it is differentiated, right? Microprocessor interrupts the first byte. It fetch an opcode. When the microprocessor is reset its program counter to 00, fetch the first code from the location 000, but in our example, it is fetch the instruction 2000H. From previous program, it fetched the 3E. When it is decode the code, it known that the 2-byte instruction, so it is assuming that the second byte is the data, right? 0E read किया तभी उसको पता चला कि it is a 2-byte instruction and the second will come to the data, right? But if we forget to enter the 32, the entire next code is 06 instead of it. So the MU will loaded 06 into the accumulator, right? So interrupt to the next code 48 is a upcode and it will continue in a wrong sequence, right? So it is analyzing that whether the code is for the 1 byte or the 2 byte. So now till now we have completed or all data transfer instruction and the process how the microprocessor is using data transfer or any other kind of instruction how it is executed, and the next lecture we will see the programming on these instructions, right? So girls, any doubt if you have? So I'll clear your doubts, please ask the questions.